Hello guys, in today's video we're gonna look at something that is called usually in the industry Spline IK solver. In this case it's a combination of things, but the biggest node in this case is gonna be called fitChainOnCurve. We're getting really close to the base solvers that I want to talk about before jumping into something way more interesting, assembling these pieces together to see how we can build something a little bit more interesting. We're not done yet, but we are very close. So the spline, this is an opportunity also to revisit a bit the idea of the twist solver, because while we're gonna build the behavior of the Spline IK, we are also gonna build a twist behavior that has additional features. So the previous solver still, it's very valid, because I believe not fitting a chain and using a bezier is probably faster. So last time I didn't use this node and I used just math. I think it's a tiny bit faster. I really don't know that though. In my brain, it's just when you need a simple twist, there is no need to involve a Spline IK. But this is something that I don't know. I think it's like that though. So the idea is that a Spline IK, it's something that relies on a spline. And in all the packages that I can think of, you have a series of transforms, and those series of transforms are basically following a spline. And a spline in this case is a bezier spline, which is a bezier spline is defined by a point and two tangents interconnected to another point, and so on and so on. And each point has two tangents to manipulate. And so the tangents can be broken or not, but anyway, so you can imagine having a curve and then having a joint sitting on it, a little bit like a motion path or something like that. So the idea is that you are then able to move the control vertices of the curve through controls, and by moving the curve you're moving the bones, and the bones are moving the geometry. So it's a lot like, the idea is to get this kind of behavior where you have a curve, the bones are following that curve, and you get this really nice behavior. And a lot of stuff in rigging, in traditional rigging, is achieved with this kind of stuff. You can mix and match FK solvers with twist and Spline IK solver to get a spine, or squash and stretchy behavior here and there, bendy arms, whatever you can think of. So let's start with the setup, like I usually do. As usual from the other video, I have a variable that is called partial name, and this is for graph reusability. I store that in a variable, I reuse it. Through that I'm looking, give me all the bones that have twist name in it. So this list contains these 13 bones. Then what I'm doing is I'm getting the first bone and the last bone, and the reason is, what I'm trying to do is procedurally place these four controls. So I'm getting the distance between the first bone and the last bone, and I divide that distance by three portions of the mesh, right? So and then what I do is I take the items, which are in this case it's not really scripted, is it? In this case are these four controls. I'm taking those items, I'm looping through them, and then what I'm saying is that I want to multiply this value here, which basically it's constant, I think. Yeah, it's a constant. And the reason why I get more is because probably it's inside an item, but this is really a constant. So basically 40 is a 120 divided by 3. 120 is the distance between point A and point B. Divided by 3, we get 40. And we multiply 40 by the index. So we get, basically this will give a position of a control every 40 units, and that's how I'm placing them. And that's pretty much it. That's the setup. Again, I like to do these things like to procedurally place the controls as much as I can, so I can reuse them. So if these were like 25 joints, they will be the same. They will still be correctly placed along the way. Why 4 elements? Because this node, finally we arrive to the forward solve, because this node draws a curve, and it creates a curve that is defined by 4 points. Point 1, point 2, point 3, point 4. And I named these controls start control, start tangent control, end tangent control, and end control. And the reason is because in reality the control points are 2, like the start and end, and these you can consider them being tangents of the bezier curve. So if you select this node, we're going to go through these options now. If you select this node, you can also have a debug setting, and this will allow you to see the actual curve. Let me see if I can make it a little bit bigger. That's the curve that has been drawn, and those little things that are flickering right now is a sampling precision, which means let me try to scale this down a bit. Basically, there are interpolated points along the way. So this curve here is now bending accordingly to this control, because this control is driving one of the input points of the curve. Now, this is our true input point. And you see this little square is representing the tangent of that bezier curve. And I can change the tangent. You can tell that it's a tangent because by moving this up and down, it's pivoting around this area. Okay. Same goes for this one. This object here, when you move it up and down, is pivoting around that area. Oh, oops. So yeah, this is the node. So very simple. You pass all the bones, you pass 4 points, and that's what you get. Bones attached to a curve, and the curve is driven by these controls. That's pretty much it. Then you have options such as stretched or not stretched, and this is pretty cool because automatically you can have a non-stretchy behavior, so the arc length of the curve is preserved, and you have a stretch behavior. You can move things around, and the start and end point are fixed, depending on what you need. You have the option to club the stretchiness. Sampling precision is the amount of interpolated points that you have. You can see these little squares here. If I move them to 20, you have more, which gives you more precision on the curve, which I guess is gonna be more precision on how the bone moves. I would never put this number higher than the number of bones. I don't think that's necessary, but maybe I'm wrong. Then we have the primary axis, and this is you may a lot of nodes have this configuration of attributes. You have primary axis. It says the major axis being aligned. This is along the bone. So in this case, positive x, which is this vector here. The secondary axis is the minor axis being aligned towards the pole vector. Okay, so if you're not using it, you can simply put it to 0. And this is basically allowing you to specify an additional transform, which I'm going to create now. Let me move this thing here and set from current, and let's see what happens if I get the control and I set the translation to be the whole vector. So this basically allows you, it should allow you, oh, yeah, sorry. Since now I specified the pole vector, I need to say, okay, what's its secondary axis? In this case, it's positive z. So the pole vector allows you to specify where the twisting direction is happening. So let's move these things around. You can see that when I bend the things, this is aiming towards the pole vector. This is what's happening. Let's remove the pull vector for now. I just don't care for now because I want to show something else. And let me put this back to 0. Great, we have that. This is pretty much it, and this I call this example number 1 because this example is really simple. Now you can see that by default it's giving me a really a behavior that's really similar to what the twist solver gave to me. So we have some kind of stretching here. I'm not going to go through the squash because it's the same idea, but probably rather than measuring the distance between these 2 points, I would measure the arc length of the curve. Maybe we can do that in a much more when we start assembling something complex. But you can see that this is giving me already some stretch because in reality it's the curve. This is the curve that is stretching. I can move these things around and I get this really nice behavior. But what happens if I twist? Well, if I twist, you can see that these 4 points, you can pass them through rotation, and it would interpolate through the 4 points of this rotation, and this is the behavior that you get, which is the behavior that you might want, don't get me wrong. But I'm taking this opportunity, and the reason why I'm doing it in this specific video is because this allows me to talk about 2 things: the Spline IK solver and a slightly different way to implement the twist on the Spline IK solver, which is very similar to what we did last time. Now, let me take the forward solver here, detach everything here, so we still have our setup event working, but now I'm gonna show 2 examples. These 2 graphs are exactly the same, but I did a thing specifically to show and demonstrate how important, due to the nature of the execution stack of this graph, which is one of the major strengths, I believe, being of controlled rig. I talked that in the first video. I did this thing because I want to demonstrate how important is the order of operations. In this very first example second, in this example, and basically these 2 graphs are exactly the same as just inverted. The blue one is this one and this one is this one. It's exactly the same thing. In the example number 2, we are first implementing the fit chain. So I have four controls, we saw that. I have all my bones. I'm going to start solving. And at this moment, the fit chain, at this very moment, the fit chain curve, in order to implement the controls following the curve, it's manipulating rotations. So no matter this blue line is saying, let this solver manipulate the rotation and position of these objects. Okay, so in this moment we are computing both rotation and translation of these objects. Cool. But then after that I'm implementing the twist, and the twist, as we know, is also a rotation. So in here I'm setting the rotation defined by the twist, and we're going to talk about this in a minute, after this first part of rotation is computed. The twist here, if I simply twist this object here, it does work the way we expect it, but instead of, like the original twist solver, instead of interpolating between 2 points, start and end, is interpolating between 4. How am I doing that? I'm simply interpolating quaternion. So we have control number 1, control number 2, give me the rotation of both, interpolate between them, multiply it by the alpha, which I'm using the ratio of the loop. Third and fourth control, so these 2, interpolate, and among these 2, interpolate them again. Oh, this node here is not supposed to be here. It won't make any difference. This was me experimenting. Apologies. So what you get now is that you get a proper twist. The twist is manipulating the rotation of these bones. Okay, so it means that I am in here, I'm manipulating rotation of these bones, And in here, after that is computed, I'm manipulating the rotation of the bones by using a different algorithm, a different input graph. So what I get is this kind of behavior, which again, it might be something that you want, but this is not really what I am expecting when I'm moving a Spline IK. I would love for these to be oriented and, you know, not collapse, like this example, like the original example, not being, basically these objects are not rotating. And the reason is I'm more overriding the rotation that this solver is computing through a rotation of 0 through here. Now, of course, you can split the quaternion into a vector and only use x, y, z depending on your choices. Absolutely, and that's the way to go. I'm just using this example to show why order of operation is important in control rig. So let's move then to the opposite. The opposite, it's basically I'm first performing the twist. So the twist does work. But based on that twist, I then computing the other two axes. The twist is manipulating the around the x, so it's twisting, like that. And then the other solver is basically solving around z and what? Sorry, this is basically my mouse being crazy. It's not it's not control rig. It's literally my mouse battery. So this is z up, and this is y forward. Okay, so now if I twist, it's awesome. If I move, it's awesome. The cubes gets oriented properly. But compared to the original, if I twist now, they twist along the chain, not around the chain. Let's see this once again. Let's move it here. I love this about control rig. You can prototype so quickly and test different graphs. So if I were to do the same thing here, I would move this up, I would move this up, and then if I rotate here, it's revolving around the curve, not along the curve. Which usually, this is what you want, usually. On a spine, on an arm, you want the twist to happen around, along the curve. But again, there are many ways to implement this. And this will give you, for example, just to give you an idea, you can have this as an arm, inside an arm. It will stretch with the shoulder. This would be the wrist attached to the wrist. These two controls that represent the tangent can be plugged. Now it's going to break, but these two controls can be, well, let's break it. Break me. Let me put this in the middle, and let's store transform to current. If I put these two tangents inside a third control, these, and then I can potentially hide these two things. Let's see, gizmo visible. So now it looks like I have three controls. I think I can then use this to achieve a bendy arm. Then you can have this thing moving here, this thing's move with the wrist. So here you will have a straight line, you can create an aim, and then here you can have a bendy arm that is nice and clean. Now the cool thing is that because these are two transforms sitting underneath the break me control, by the way I didn't break it, so I'm going to rename this don't break me, doesn't break me. I think it's because I'm using already local values on the graph. Because these two things are sitting under, you can do things like scaling, and because it's literally scaling the two controls that are underneath, you can change the way the curve is interpolated, because you're making the tangents making closer or far away, right? So you have a more round thing or a more sharp corner over there, and that's how you could do. It's one of the many ways to do a bendy arm, for example. Anyway, I hope in this video we saw different things. We saw this node fitChainOnCurve, but we also discussed about how to place procedurally controls when it's not the same number of joins. We've done this in many videos before, and then we saw why the order of operation it's important, and then we saw how to implement twist along the curve rather than around the curve. That's it. Thank you. Bye.